Okay, today, guys, I'm going to go over 3.3, a little follow-up just to make sure that you guys are able to do this. The book does it a little out of order, so I just want to do it right now. And then we'll go over a little bit of 3.4, probably not too long of a section, just a few word problems to kind of practice from 3.4. So the thing is, so it says find the following for f of x equals negative 3x squared plus 6x plus 1. And I want you to find all of this stuff, okay? So again, we are supposed to know a lot about parabolas at this point in our life. If you don't, you guys definitely got to practice a little bit extra in this section. And if you feel pretty good about parabolas, you might be okay. So first thing we know is that to find the vertex, we have two main options. We can do completing the square, or we can do the faster negative b over 2a, and then f of whatever we get. So I'm going to do negative b. So this will be negative 6 over 2 times a, which is negative 3. So this will become negative 6 over negative 6, which is 1. So now I'm going to do f of 1, and that's going to be what? Negative 3 plus 6 plus 1. So that should be what? 4. So that means we now have a vertex of 1 comma 4. And that's all you do. That's all you do to find the vertex. That's how we did it, okay? Now the axis of symmetry is linked to the vertex because it's always the x coordinate. So all you have to do is say x equals 1, and you now built your axis of symmetry. So if you get the vertex right, you're also going to get the axis of symmetry right. And remember, the axis of symmetry is the line that just cuts a parabola right in half. Now the x-intercepts are going to require a little bit of work because I can tell by looking at this is not factorable. Okay, so in the last video, I showed you how to use your calculator to do it. Now I want to show you how to use, or hopefully you already know how to do the quadratic formula. You guys know that the quadratic formula says that, so this is the quadratic. And the quadratic formula is for ax squared plus bx plus c equals 0. And it says that x equals, you know what, I'll write it in red because it's so important. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that is the quadratic. This is your a, the number in front of x is your b, and the number without an x is your c. So this is an extremely important formula. This is one of the few unbeatable formulas in math. Some formulas always have like, well, it works, but not in this case or not in this. The quadratic always wins, even for imaginaries. It can also find you the imaginary answer. So the quadratic is pretty bulletproof in terms of what it can do, but it in general only works on quadratics. That's the main stipulation. So we have a quadratic right here. So we're going to do the quadratic formula because I know this can't be factored. And when something needs the quadratic formula, that means the answer is probably going to be really ugly, okay? It's going to not have a nice outcome. So what we're going to do is negative b, so that would be negative 6 plus or minus the square root of b squared, which would be 36, minus 4 times a, which is negative 3, times 4ac, and then c is 1. And then we're going to divide all of this by 2 times a, which is negative 3. So let's see what we get. We end up with negative 6 plus or minus 36 minus, or was that plus 12? So we know that that's what, 48. All divided by negative 6. So now we have x equals negative 6 plus or minus. Now I got to take 48. And I got to clean this up. So 48 is really 8 times 6, but this is really 4 times 2, and this is really 2 times 3, and this is really 2 times 2. So here's a pair of 2's, and here's a pair of 2's. So 2 times 2 is 4, so hopefully you guys know how to clean up your radicals. If not, you definitely want to ask me about that. So we get 4 square roots of 3 all over negative 6. Now, we have to look, what does this, and this all have in common? They all have a 2 in common, so I'm going to factor out the 2. So this will become, you know what, I'll factor out the, you know what, we can also, before I do that, we can take this negative and apply it to everything. So this will become 6 plus or minus 4 square roots of 3 over 6. So I was able to move the negative up top and cancel out the negatives. So now I'm going to cancel. Oops, this will factor out a 2, and this will be 3 plus or minus 2 square roots of 3 all over 6. Now I can cancel this 2 with this 6. And this becomes 3 plus or minus 2 square roots of 3 over 3. Okay. So now that's technically the answer, but you know, I may ask you to approximate. So if we want to approximate, we're going to say 3 plus 2 square roots of 3 divided by 3, and we're going to say 3 minus 2 square roots of 3 divided by 3. So I'm going to do that. I'm going to do 3 plus 2 square root of 3 divided by 3, and I get approximately 2.15-ish. And then for this one, I get negative 0.15, I think. 3 minus 2. Yeah, negative 0.15. So this is what I'm going to say. Now, these are the exact answers. So if I ask for exact answers, you have to leave them like this. But because we're going to have to draw this, I probably want the decimal approximations. So I'm going to say that my x-intercepts are 2.15, 0, and also negative 0.15, 0. Those are my two x-intercepts. Okay. My y-intercept is easy. Remember we said that the y-intercept is always just c when you're dealing with parabolas. So that means my y-intercept is just 0, 1. Okay. So in reality, the only one you had to work a lot for is the x-intercepts, which are just the zeros of the function. So now the domain is always negative infinity to positive infinity for vertical parabolas. The range we'll hold off on. Now, max and min, I know how to find that. Oh, vertically stretched. Now remember, vertically stretched is based on this number. If that number is, the absolute value of that number is greater than 1, then it's vertically stretched. If that number is smaller than 1, like a fraction, like 1/4 or 1/3, then it's vertically compressed, or like somebody, it looks like somebody mushed on it and mushed it down. So I'm gonna say that this is vertically stretched by factor of 3. And then we know that it is concave down, since a is less than 0, right? Because a is negative, right? Because a is negative right there, we know that this is concave down. So the only thing left we need is the range and the max, and you'll see why I waited on those. So let's do this. So say it's 1, 2, 3, 4. 1, 2, 3, 4. Oops, put it over there. 1, 2, 3, 4. 1, 2, 3, 4. What was our vertex? 1, 4. So I'm going to go over 1, up 4, put a point. And now our x-intercepts are 2.15, so I would guess that's right about there. And negative 0.15, I would guess that's right about there. Our y-intercept, we said, was 0, 1, so that's right about there. So it's kind of looking decent. And then, oops, this kind of is off a little bit. Let me say it's right about there. So I'm going to then try to draw a parabola. Kind of like that, I guess, right? So that's my parabola. Okay, and then my axis of symmetry goes right down the middle like that. That's my axis of symmetry. And this number right here, is that a maximum number or a minimum number? That vertex, 1, 4 is a maximum, okay? So we come over here and we're gonna say the max value is 4. Remember, normally when they ask for the maximum or the minimum value, they want the y coordinate. The range would be also from right there. We go from negative infinity to 4. The highest value this graph will ever reach is 4. And because it has arrows, it will go down forever to negative infinity, okay? So this is kind of a standard test question. It might just ask you a bunch of information about a parabola, so you have to be able to do all of this. It looks pretty bad, but if you know your parabolas, it's not too bad. It's just a lot of information, okay? And this is about the level of work I would need to see on your exam, okay? So when you submit this problem, I should see this work all over your exam, okay? If you don't show work, you know, I'm going to take off points. So You don't need to show work for this, right? Because the axis of symmetry you can find, you know, from the vertex. You don't need to show work from this because that's a super easy problem. You don't need to show work for this. That's super nice. The range comes from the vertex. That's super nice. The max comes from the vertex. That's super nice. This comes from A. That's super nice. This comes from A. That's super nice. So really the only things you have to work for are the x-intercept and the vertex, and everything else is just knowledge, just things you know, okay? So please try to keep that in mind, that I do need to see some work, but a lot of this stuff is just things you know, okay? So now let's move on. That was kind of my follow-up to 3.3. Make sure you know how to use the quadratic equation or formula. If you don't, you know, talk to me and we can go over a couple extra. The main benefit of the quadratic formula is when something is unfactorable, but you still need to find the solutions to the quadratic, you can just use the quadratic formula and you always win, no matter what. Okay, so for this 3.4 is about building quadratic models. Okay, so we're going to build quadratic models, kind of like we did with linear models, which basically means we're going to do word problems. Okay, so let's suppose a farmer has 2,000, let's say 3,000 feet of fence. Oops. 3,000 feet of fencing and wants or wishes to enclose a rectangular field that borders a river. He or she does not need to fence along the river. So it's like a natural barrier. So they can save a little fencing. What dimensions of the fence would maximize area? Okay, so I want to know what size of fence should I be building that will help me maximize the area that I can enclose. Okay, oh, geez, it's pretty ugly. Let me fix that. Okay, so with these type of problems, in general, I would say the best thing to do is to draw a picture. So I'm going to draw a little river, and then they're going to build a rectangular field, or I'm sorry, a rectangular field along it, but they're going to enclose it with fencing. And let's call this my length, and let's call this my width. But if that's the width, then that's also the width over there because it's a rectangle. Now, the funny thing is, in a way, it's kind of a three-sided rectangle because we're not using fence along the river, okay? So if you're calculating how much fence is going to go around something, all you're really doing is finding the perimeter. So we know the perimeter for this shape will be L plus 2Ws has to equal 3,000 feet of fencing, right? So if we add this distance up, we add this distance up, and we add this distance up, it's going to be 3,000 feet of fencing. So I don't know what L is and I don't know what W is, but I know that that's how I have to add it up, okay? Now the problem is we are not trying to maximize perimeter. So in general with these problems, you're gonna have one formula or one piece of information that you write down that you know based on what they give you, and then you're gonna have to come up with a formula that you're trying to maximize. So in this case, we're trying to maximize the area of a rectangle. So that would be length times width, okay? Now the good news is that I can come over here. Oops, why is that happening? Okay, so length times width. Okay, so the good news is I can come over here and I can say A, oops, you know what, I meant over here. I can solve for L. L equals 3,000 minus 2W. If I just subtract 2W over to the other side, right? So now I have a replacement for L. This is a substitution method. You guys should have learned this before. So I can take this and plug it into here. So I have 3,000 minus 2W, okay? So now I have A equals 3,000 minus 2W, that's L, times W, oops, times W. And remember, this is just L times W, that's all I'm doing, okay? Now if I distribute this a little bit, oops, I get A equals 3,000 W minus 2W squared. But in reality, that's really negative 2W squared plus 3,000 W, okay? So here's the thing. What shape did we just build? What shape has a squared, right? That's a quadratic. And if it's a quadratic, the quadratics you now know, look at all this information you know about quadratics. Now think, which one of these things that are on this board or on the screen is going to pertain to a way to maximize area? Well, right here, we have maximum value, and we're looking for how to maximize area. So what do we need in order to find the max? We needed the vertex. So all I have to do is come down here, and I have to find the vertex. But in order to find the vertex equals negative b over 2a comma f of negative b over 2a. Right? That's the formula for it. So negative b over 2a would be negative 3,000 over 2 times a, but a is negative 2. So all I'm going to do is I'm going to do 3,000 divided by 4, and I get 750. So that means, and remember, this is technically a based on w. This is a of w. So normally, you know how you find f of x? This is my x and this is my y. But in this problem, because we're not dealing with x and y, this is my w and this is my area, okay? So I just found my w, okay? Now, if I want to know the maximum area, which might be a follow-up question, I would just do f of 750. I'm sorry, a of 750. So this will be negative 2 times 750 squared plus 3,000 times 750. So this will be, let's see here, 750 squared times negative 2 plus 3,000 times 750. So I get 1,125,000, 1,125,000 square feet or feet squared. So that is the largest area, and W is the dimension that makes it happen. So we say W equals 750, but now look up here. If W is worth 750, well then I can plug 750 right here. I can plug 750, 750 right here. And then I can find L, because 3,000 minus 750 minus another 750, look right here. I can find L, right? Oh, I'm sorry, I already have it over here. L is worth 3,000 minus 2 times W. So that would mean L equals 1,500, okay? And then the maximum area that we could enclose with 3,000 feet of fencing is 1,125,000 feet squared. There is no bigger rectangle or three-sided rectangle that we could build that would hold more area than that. Other things might get close, but nothing could ever be bigger than that because we found the maximum area and we used a parabola to find it. And once again, remember, what you're saying is you have this parabola right here, and I don't know where it goes, but it's something like this, right? This point right here is 750, comma, 1,125,000, right? That is the XY coordinate, but in this case, our axis is W and A, area, because it's A of W, okay? But it's basically X and Y, just like you're used to dealing with, okay? So L is 1,500 feet. And that would be our answer. And I don't want you guys to guess. There are ways to guess this. I don't want you guys to try to guess. If I ask you on the test, you have to show me your work. You can't just all of a sudden magically say, oh, I have 750 feet and 1,500 feet. On the exam, you have to show me this work, okay? So basically what we normally do is we draw a picture. Okay, write down info that is given. Right? And usually solve for a variable to sub into another equation. So from the info that you were given, you normally will have some information that will allow you to substitute into another equation and then answer the question. So if they're talking about max and min, when they mean answer the question, that means you need to find the vertex so you can find the max and the min, or the min value, okay? So let's go through another one. Let's see here, it says, let me see here. So in economics, revenue, big R, in dollars, that is a lot of commas, is defined as the amount of money received from the sale of an item, and is, to the unit, and is equal to the unit selling price P in dollars. This is a sentence from your book, but it is such a run-on sentence, of items times the number X of units actually sold. Okay, so that's a fancy way of saying that R is equal to X times P. So you take X being the number of units sold times the price, and that's your revenue, okay? So in economics, I'm not an economics major, but they talk about it in your book, and it says the law of demand states that P and X are related. As one increases, the other decreases. The equation that relates P and X is called the demand equation, okay? So it says find the model that expresses the revenue as a function of the price X. So we're gonna do this problem here. So it says the price P in dollars and the quantity X sold of a certain product obey the demand function. Oh, demand equation, sorry. Okay, so we have P equals negative 1/6 X plus 100. This is what they're telling us this particular product it sells for. And then the X has to be between 0 and 600. So this company can't produce less than 0, but it also can't produce more than 600, okay? So part A says, find a model that expresses revenue as a function of X. And this is normally what they want. They want you to write it as one variable, a function of the price, which we know is X. Okay, so what we need to first do is we just write R equals X times P, but we know that P is actually negative 1/6 X plus 100. So this is actually negative 1/6 X squared plus 100 X. Now, once again, what does this look like? This is now a parabola, once again. So we now have R of X, the revenue based on X of negative 1/6 X squared plus 100 X. So that is our revenue function, okay? Now, once we have this, they can ask us questions. They can say, what is the revenue if 200 units are sold? Okay, so then all we need to do is we just do R of 200, and that equals negative 1/6 times 200 squared plus 100 times 200. And I'm just going to do this on my calculator. So I'm going to do 200 squared times 1 divided by 6. And then I'm going to do plus 100 times, wait a minute. I forgot the negative sign. So 200 squared divided by negative 6, or multiplied by 1/6. Okay, now I'm going to add 200 times 100, and I get 13,333. And I'm going to round off to 34 cents. Okay. Okay, so we get 13,334, 3,333, $13,333.34. Okay, so that's how much revenue we would get if we sold 200. Now the next question could be, what X would maximize revenue? Right, that makes sense. That's totally a question that someone would ask. If you're doing all this work to find the revenue function, wouldn't you want to know how many units is the perfect amount of units to sell? And then what is the max revenue? Right, you're going to do all this work to find the revenue function, but not then actually use it for what it's for. So we want to find the maximum revenue and what value would make it. So we know that the vertex gives us the maximum. Again, we know this is a downward facing parabola, so it has a max. And again, the reason I know that is because there is a negative in front. Remember, when you have a negative in front of your x squared term, it is a downward facing parabola and it will have a maximum. So what we're going to do is we're going to find the vertex. Vertex equals negative b over 2a comma f of negative b over 2a. Okay, so we're going to find that down here. So negative b, so in this problem, b is 100. So negative 100 over 2 times a, but we know that a is negative 1/6. So now we're just gonna hit enter on our calculator. We're gonna do, what is that, 50 divided by, parentheses, 1 divided by 6. So we get 300, okay? So that means that X equals 300 units sold would maximize revenue, okay? And then what would the max revenue be? Well, then we just have to do R of 300. So just like up here, we did R of 200, we do R of 300. So we're just gonna do negative 1/6 times 300 squared plus 100 times 300 and see what we get. So I'm gonna do 300 squared on my calculator divided by 6 times -1, right? So it's a negative 15,000. And then I'm going to do plus 100 times 300. And we get 15,000. Okay. So $15,000 is the maximum revenue we can ever make with this particular manufacturing. So the thing is if you want to increase revenue, then something would have to change. Either, you would have to mess with your price function or something, okay? So in general, this is how you can use parabolas to work with business models, okay? So let me zoom out so you guys can kind of see all that we did. Kind of a lot, right? We did a lot with this problem, okay? A follow-up question might be, what price should the company charge to maximize revenue? Well, then I think what we could do, let me see, I didn't do this, I didn't work this one out. We could do 15,000, that's our max revenue, and that would equal negative 1/6 x squared plus 100x. So then we could do 1/6 x squared minus 100x plus 15,000, set it equal to 0, and then we solve. And we would use x equals, we would use our quadratic formula now. So we would say x equals negative b, which would be 100, plus or minus the square root. And all I did, you guys, by the way, is I added 1/6 x squared plus 1/6 x squared over to the other side, minus 100x minus 100x, cancel, and we now have 0 over here. Because remember, when you're using the quadratic formula, you always need it to equal 0. That's your first job, is to set it equal to 0. So we have 100 plus or minus the square root of b squared, which would be 100 squared, so that would be 10,000, minus 4 times a, and a is 1/6 this time, not negative because we moved it to the other side, times c, which is 15,000, all over 2 times a, which is 1/6, right? So let me get some decimal approximation on my calculator. I'm just entering it in my calculator. Minus 2 divided by 3 times 15,000. Oh, it's going to be 0. Okay, so those cancel. So then we're left with 100 plus or minus the square root of 0 all over, what is that, 2/3, right? Because 2/6, oops, not 2/3, 1/3. 1/3. Okay, and then you guys can go from there. I just had something come up right now, a little bit of an emergency. So I'm gonna have to end this video short, but if you guys have questions about this, this is how you would solve it, and just plug that value in. That would be the price function. All right, thanks you guys. Thanks for watching.